Okay, how's everyone today? Yes? We're going to capture, they want me to speak with an Eastern Oklahoma accent. I'll do my best today to speak with an Eastern Oklahoma accent. Here we are outside Muskogee at Muskogee High School. Okay, well, you don't see a lot of whales in Muskogee, Oklahoma. That's near the Arkansas border. Anyway, it says somewhere, I'll find it in a minute. Here it is. I just don't know where it is. Here it is. To capture its prey, a whale will create a cylindrical wall of bubbles beneath the surface of the water, trapping confused fish inside. If an air bubble has a volume of 5 cubic centimeters, that's 5 cubic centimeters, at a depth where the pressure is 200,000 PA, that's 200,000 PA. What is the volume of the bubble, an individual bubble? What's the volume of an individual bubble just as it breaks the surface? Now understand the surface is 101,000. So you're creating a 5 cubic centimeter bubble, right, at 200,000 PA, pascals, right? Now, when it hits the surface, it's going to be 101,000. So is the bubble going to increase in size or is it going to decrease in size? Is the bubble going to expand when it hits the surface, or is the bubble going to contract when it hits the surface? Which is it? Jack, what do you think? It's going to increase the size of the bubble. Bubble's going to increase because you're decreasing the pressure, you're increasing the volume. Volume and pressure are inversely proportionate. Understand? Yeah? Okay, they got it. Okay, now, I got some data, as we say back home, some data. Okay, we got some data back home. And it's 200,000 PA is the first condition. The first condition, pressure. First condition, 200,000 pascals. That's where the bubble is created. Now, the bubble has an initial volume of 5 cubic centimeters. 5. Count them. 5 cubic centimeters. Now, understand this. That if I want the answer in cubic centimeters, then you put the answer in cubic centimeters. But if I want the answer in cubic meters, you have to convert from cubic centimeters to cubic meters. Just keep that in your mind for a moment, okay? Now, when it hits the surface, it's going to have a pressure that's less. And that pressure is going to be 101,000 pascals, PAs. Now, what we've got to do is we've got to apply a law, Boyle's law. Mr. Boyle was actually born in Ireland a long time ago. He was a physical chemist, and these are gas laws, but it's the study of physics. But why is it important to study gas laws in chemistry? Anybody? Well, it's important to study gas laws, which are physics, in chemistry, because oftentimes the chemical equations, the chemical reactions, are occurring in a physical environment. So you have to know things about the physical environment. If you produce a gas in the chemical reaction, you're increasing the pressure, correct? If the reactants are in the gaseous phase when you're starting the reaction, then you're going to have changes in pressure, volume, and temperature maybe. Understand? So it's important to understand physics when you're taking chemistry. Yeah? So let's plug into Boyle's equation and see if we can root out the solution, okay? All right, so we have 200,000. Is that right? Is that right? Yeah. 200,000. I'll leave off the unit labels, it just looks cleaner. Okay, as long as you know what you have. We have pascals and cubic centimeters, so if you're going to calculate the volume, it's going to be in cubic centimeters, and that's all right today. Now, I might convert it, I'll show you how to do that, but we're going to calculate it in cubic centimeters, okay? All right. So, the initial volume is 5. Equals the new pressure, which is 101,000. Everybody understand that? Everybody have that? Yeah. So what's the answer? 200,000 times 5 divided by 100 in 1,000. Going to be what? Ish. What is it going to be? 9.9. Going to be 9.9, which is about right, because you're kind of cutting the pressure in half. So you're going to cut the pressure in half. You're going to divide it by 1/2. So then you're going to multiply the volume by 2, which is the reciprocal. Understand that? So if you halve the pressure, you double the volume. You double the volume, you halve the pressure. You double the pressure, you halve the volume. You understand Boyle's law? Volume and pressure are indirectly proportionate. Understand? Okay? So the answer would be 9.9. Is that what you all said? 9.9 cubic centimeters. Now, let's change that to cubic meters just for a second. It's real easy to do. Okay? How many cubic centimeters are there in a cubic meter? You should know this right away. Well, how many centimeters are there in a meter? 100? 10 squared? Yeah? 10 squared? What happens when you cube 10 squared? What do you get? What happens when you cube 10 squared? You get 1,000,000. There you go. You get, who said that? Leif? Leif Erikson? Leif Erikson said that. Excellent. So 10 squared cubed is 10 to the 6th, right? Understand that? Jack, you said that too, right? Okay, now, so what you do is you're going to multiply that by 1 over 10 to the 6th. 1 over 10 to the 6th centimeters cubed. And so that's going to be 9.9 times 10 to the negative 6 meters cubed. Understand? Yes? So you could put, if I asked you for the answer in cubic centimeters, volume 2 would be 9.9 cubic centimeters. But if I asked you what is the answer in cubic meters, it would be 9.9 times 10 to the negative 6th cubic meters. We're done. We're done. Understand? See you later. Oh, yeah.